Wow. Welcome. What a pleasure to have you here. Let me take you on a time travel. This is August 1998, my first day of school. This is me, little girl with glasses and a yellow dolphin-themed cardboard cone full of candy. Like, how much better could this day get? I was so excited for this new stage in my life. I felt really grown up at being a school kid, and yeah, I was so eager to learn. The excitement didn't last for too long. It's like this downward trending graph represents the continuous downgrade of my passion and understanding for maths. Maybe some of you can relate. I was desperate. My parents paid private lessons, and I just couldn't lift my performance above average for many, many years. Until I changed school, and having this new teacher who explained things in a different way somehow really flipped the switch. I feel that a lot of Tableau users go through this kind of disillusionment as well. They have a particular viz in mind that they want to create, and especially with time-based analysis, something like the last sentence there, I need the current month and quarter to date, year to date, as well as quarter over quarter in dollars and percent. I'm like, okay. There are so many questions like this on the community forums, and I thought this is such a relevant session to teach you about how to do this time-based analysis and period comparisons in an easy way. Welcome to the greatest of all time analytics. I hope you could sense from the title that this is all about date functions and time-based analysis. My name is Johanna Knapp. I'm based in Frankfurt, Germany. I've been working with Tableau for 2.5 years now. I recently stepped into the team lead role for the German-speaking market and also Central Eastern Europe. In terms of agenda, first we'll cover the very essential topic of what are date parts versus date values. I know this is an advanced session, and you can start thinking now whether you know the difference or not. Start thinking. I feel this is critical to explain because it is the fundamental for doing date arithmetic. After that, I'm going to present 3 examples that I consider best practice for KPI dashboards or performance analysis to show what do we want to get to? What does good look like? After that, we'll spend most of the time with time-based analysis. We're going to write a whole lot of calcs. We cover all the date functions that Tableau has. And the examples I want to demonstrate here are year-to-date versus previous year-to-date, also with how to do that based on a fiscal year that's different from the calendar year. After that, time to ship, excluding weekends, as well as a quarterly performance across weeks of quarter to get sales linearity, and a KPI number for customer acquisition. A bit of housekeeping. So for sure, the slides will be available to you as a PDF distributed by the Tableau conference team. The workbook, to make sure you all get it, will be uploaded to my personal Tableau public profile right after the session. So you will have it today if you go on Tableau public. I'm happy to answer any questions after the session directly one-on-one because we'll need all the time for those date functions. And finally, as a friendly reminder, I'd be glad to have your feedback on the mobile app. Also, to proudly show it to my parents who supported me so much and paid my private lessons, right? Thanks, Mom and Dad. As a disclaimer, everything I tell you today will not make any sense if your data source doesn't have one of these 2 kinds of date types, either date or date time, on your dimensions. on the column that contains your date. I think this is a given. Everyone knows what I'm talking about. So let's quickly unravel the difference between date parts or date values. Who of you has seriously thought about the difference? A couple of you? Good. So the first experience you get with Tableau, if you drag your date dimension out into the view, is that Tableau aggregates everything to the yearly level and gives you a blue pill, right? So this is the date part. There are also other date parts that you can access from the drop-down, the context menu. And this default behavior makes it so easy to work with dates in the first place. Just imagine how difficult it would be if Tableau didn't have that kind of behavior. So the date parts result from the date part function. So if you use that, you will get 2018, 4, 10, 24 for the day, all by themselves and individually, right? This is the date part function, and that's what you will get from it. The other date parts, like week, weekday, and day of year, are pretty handy, and we'll use it later on in the session. Since Tableau version 18.2, we also have ISO standard date parts. What is that? Is anyone from Europe in this audience? Yeah, a bunch of you. For all of you, it will be super relevant because the Gregorian calendar that is used in the US critically differs from the ISO standard calendar that is used in Europe and other parts of the world. And what critically makes a difference are the week numbers. So you can use that, these date parts and date functions already if you're running an hyper extract. So what about date values then? The default behavior is this continuous axis based on a date value, and I often hear people talk about continuous dates. It's not quite correct. It's just their default behavior. So what you get is essentially something that's created by the date trunc function underneath. So it will round, for example, this granular timestamp on the second level up to a minute level, depending on the date part you specify. So that is what happens behind the scenes. I don't know if you ever thought about that. For everything from week going to year, it will be rounding, right? It will be rounding your date to the particular day that specifies the first day of the week, first day of the month, quarter, or year. So this is very important to know if you want to put conditions on your date and do period comparisons. So what do we want to get to now? What are these good examples and what can good look like? I'm sure every one of you has been working on a so-called KPI dashboard. I'm curious to know what yours looked like. This is one of our dashboard starters that are available on Tableau Online. They're also available for download if you're using Tableau Server or just generally want to connect to your Salesforce data with Tableau Desktop. What I want to draw your attention to is this line chart in the middle of the screen that runs across week of quarter. It gives a ton of valuable insight because I can see the linearity of sales towards the end of the quarter. I can also see how far the current quarter is from the current target, right? And the lines that I want to compare, they stand out to me because they are colored in a different way. Some of you in here might think, like these big numbers at the top, that's the real KPIs I want to have. Ideally, my boss would like a traffic light indicator or percent growth metric next to it. And you can totally do this in Tableau. But these KPIs, they don't always need to be following a red, amber, green scheme to show whether it's good or not. Tableau Zen master and speaker at conference Adam McCann shows us, with his take on visualizing KPIs, that it doesn't need to be like very plain, but it should use visual attributes like color, position, size, and so on to make it visual and give you some context around how to interpret this big number that you see there. The second and third and very popular example done by Lindsay Poulter for Makeover Monday in 2016 is something that some of you might have already seen. So this is a very popular dashboard from the Tableau community. Admittedly, it's so popular that Zen master Andy Kriebel has been inspired at least twice by Lindsay's design, and he recently visualized KPIs for historical avocado prices using these bullet graphs and the spark lines underneath. So what is great about that is that these bullet graphs do not only lend themselves well to do a kind of actual versus target comparison, but in this case, it's also a current period versus previous period comparison to see if this number at least exceeded the previous period's actual. And these spark lines underneath, they just provide more context around when a certain target or certain number has been met or not in the past. So what I want to do today is to actually create the best Superstore metric scorecard I can possibly produce in this very session. Let's see if it will look like one of these examples in the end. We'll do that one chart at a time, and we will start with the year-to-date versus previous year-to-date comparison inspired by Andy Kriebel's avocado KPIs. So what you see here, and I hope you're with me, is the bullet graph. The challenge here is that we only have 4 marks. So you can see we have those 4 bars. And what we ultimately have to do is put some sort of condition on it. It won't work to just use a filter in order to get a bar that just displays the value if it is for the current year, as well as only up to today, so anything till the 24th of October, essentially, versus a reference line that shows everything 2017 till 24th of October 2017. So how to do that? We will use the date part function for this year-to-date calculation. And we will put conditions on here. So if the date part, and here we'll use day of year of this particular transaction that you have, so that's order date for Superstore, equals, is smaller or equal to the date part that is also year, day of year for today. That's our first condition, right? So I'll make it a bit smaller so you can see all of it. So if at least this is true, and as well, we can use the year function that is similar to the date part of year of order date equals the year of today. Then we want to show our sales, and that's it. So ultimately, we have put these conditions onto our metric, and the database table will only return that. So there's a missing. Good. And once we drag that out, this will display only the year-to-date value for the particular sales that we want to get. The previous year-to-date is the most easy thing to do after this, because I simply need to duplicate that, rename it to year-to-date previous, and very simple math that even I can do is to put -1 behind the year of today, which would get us 2017, and both conditions are met to get to our previous year to date, because day of year is uniform across all years. So let's put this to detail then, and use a reference line on the cells to get us that nice big orange reference line, so we can see how far the regions have already outperformed the previous year's number. And with another quite simple calculation and easy maths that everyone learned in school, we can calculate the percent difference. You know what the formula is? So we're going to first create the difference between those two values and divide it by the previous one. So once we drag this here, I'll just make it discrete really fast, because in order to move it as a text value next to our region, it needs to be discrete, and we will format it as a percentage. Here we go. Easy as that. So if the layout really needs to be like this, the row level calculations are the best way to achieve that. No filters, no additional level of detail needed for this kind of viz. So if you increment or decrement those dates, either using the year or month or day function or date add, then you will be able to define those conditions that would return the particular metric just for the basically condition that you defined, right? Be careful, though, when doing simple maths, like order date -1. You might end up with unexpected results, because some databases store dates, in fact, as an integer, a really long integer, like 49,536. If you subtract -1, you just won't end up with a real date anymore. So basically these conditions, and if you want to make it relative always to the current date, you can use today to make it behave dynamic and to define these kind of upper and lower boundaries, right? In contrast, I want to show you this example, which is totally different from the bullet graphs that we saw. These are the spark lines, called like this because of the little indicator at the end of the line that shows us the most recent value. Here we do have quarter of order date in the view. So in fact, there are 68 marks, and we already have our time-based information in the view. What does that mean if we want to have a quarter percent growth metric? We can take this right off this viz, because the numbers that we need are already there. So for example, if I hover over one of these points, that would give me the value that I need, and the last point would give me the value that I need to calculate this percent difference. So here we would use table calcs. First of all, to get this little indicator at the last mark of each line, we can use the function last that ultimately indexes our marks in the view. If this equals 0, then we want the sum of our sales, and that's it. So what this does, it created a really small little circle. I'll make it a bit larger. and create a dual axis and synchronize that one so that we get the bubble at the end of the line. So what about the percent difference then? Also here we could use the last function in table calculations. So that would be the similar syntax that we already used for the percent difference on the bullet graph, namely a lookup where sum of sales stands at the last mark in the view, minus where it stands at the previous one, so that's last minus 1, and divide that by the previous value here. And we're missing bracket, and here we go. So that's the correct calc. I'll also make it discrete and move it next to those regions, and ultimately format it as a percentage. The message I want to give here is that it really depends on the layout of your viz, whether you use a row-level calculation or a table calculation. It depends on the number of marks you want to have in the view, and it depends on whether you already have the values or not, if you need to bring it up from the database table itself, or you have a viz that is already laid out like that. The next example, and I can imagine this is a challenge in many cases, is to get the right number if you just have one single mark. You just want one big number or one symbol, like in this case, that would display, for example, what is the average time to ship excluding our weekends. Let me tell you that, I'm from Germany, and I don't know if you know, but stores don't really operate on a Sunday, for example. You would need to pay workers more if they work on weekends, so many businesses might not want to even open up on a weekend. So if we have that kind of shop, and we also have a mail that is maybe not as highly received on weekends as it would be on weekdays, then this becomes a really relevant analysis, right? So Superstore, you can see, has quite a lot of orders placed on weekends. After all, it's e-commerce, right? And also shipments take place on Saturday and Sunday. Here we see a viz with the weekday date part. But in fact, once you see Monday and Tuesday, it really is just the formatting of that. So if we switch the formatting to numeric, you can see that actually these particular weekdays are numbered from 2 to 1. So what can we do actually to get rid of those weekends? One approach would be to basically shift any day on the weekend, like the 7 and the 1, the Saturday and Sunday, to the following Monday, and just pretend that we did only receive the order on that particular day. So I have a calc with the adjusted order date, which basically says if this date part falls on a Saturday, we will shift it 2 days forwards to the following Monday. If it's a Sunday, we'll also shift it forwards 1 day. Otherwise, we're good to go. And we do the same with ship date and just shift it back. So we just do ourselves a little favor and pretend that the shipment was received way earlier than it actually was, just to get our KPI more representative of the overall circumstances. So here we got our orders, And if we want to know what is the duration that it takes from order to ship date, this is the really simple calculation I believe every one of you has done before. Now we're going to do this using our adjusted order dates and ship dates. So this is adjust ship time, and it's going to be the date diff in days between our adjusted order date and adjusted ship date. As we want to factor out any of the weekends that are between these two dates, for example, if we received an order on Wednesday, and it will ship the following Thursday, for example, there is one full weekend between that. So we can simply subtract basically the duration it takes in weeks between those multiplied by 2, because we have 2 days on a weekend, right? And we would end up with that particular metric. So if I put adjust ship time here and take the average of that, it looks a little bit better. But what strikes me is that this axis here somehow has negative values. If we'd scroll down, we could see that the same-day deliveries that we had on a weekend, for example, just get really screwed up because we shift things back and forth and have a negative duration then. We can basically work around that if we say that once a shipment was made that took less than 0 days, so it was negative. Then we say that will be like an immediate shipment, no duration at all, 0. Else we want our regular calc. And here we go, fixed. Now I want to know what the average ship time was. Super easy with drag and drop, right? Just put an average line onto this table, and we're going to find out, if it appears, that the average ship time is 2.61 days. So what will happen now if I want to get a single KPI from it, right? So I remove all this detail that I don't need, also get rid of the old function. And why is my ship time now 2.62? Anyone? What would you do now? What does it screw up? LOD. We need an LOD here because our data is basically line items from online purchases. So we need to include our order ID again in order to get the right number here. So I can quickly customize this with a quick edit and include order ID and fix it to the average adjusted ship time. And of course, take the average, but not the sum. And then we end up with our KPI that shows the correct number. So oftentimes, if you're working with data that is very granular and needs to be calculated at a different level of detail, for KPIs, you need to use LOD functions, but that completely depends on the structure of your data. If we wanted to have one single KPI now, for example, so I'll just drag order date again because I had this visualized by year, right? I wanted to show the metric for 2018. And also, like in Adam's example, he put percent difference to the previous years on color. So this is the quick table calc, percent difference. And of course, we need to reverse the color scale because an increase in ship time means that's bad. After all, just filtering to 2018 will not give us that nice percent difference, right? So we cannot use filters here, but rather we need to use a table calculation filter again. So I've already explained to you the last function, and the last mark in the viz would be 2018 here. So that's something that I do all the time actually, is to evaluate if this is the last mark in the view. So last equals 0. And move this onto filter, tick true, and only get, a little bit thick bar. That could also be the symbol or another mark type to just give you a nice and visual KPI and just the mark that you need. All right, so now that we've seen the date diff function with a traditional use case, an order and ship date, what kind of novel ways can we come up with for this kind of function? So turning to this view of sales linearity that goes or runs along week of quarter, we can see that we basically have to compute the week of quarter in order to align all of these historical ones onto one particular axis. So if we would start out with this view, we would have all these different lines along the axis that also has the yearly level. And we need a way to bring it onto the same origin. You can use date functions nested within date functions, and that's what week of quarter is as well. So if we compute the date diff in weeks between the start of the quarter, and here we need the date trunc functions again, date trunc quarter of order date will give us the start of the quarter, and the actual transaction will give us that week of quarter essentially. Because we don't want to have week 0 for any date that's within the first week, we also have to do a +1. And I can move this and replace my week of order date with that. And we see all those lines that are not visually distinguished from each other. We do want to compare the current quarter, the previous one, and the same quarter for last year. So how can we do that? Also with the date diff function. So we create a calc for the standout quarters. And we can say essentially if the date diff between in quarters between the current one and today equals 0, then this is the current Q. So for me, when I came up with this session, that was a quite novel way to do this actually, to use a date diff function to basically compute those offsets. We can just do the same for the other ones, because if that equals 1, this will be the previous Q. Otherwise, if it's 4, if we go 4 quarters back, it's the same quarter last year. Otherwise, I just want to label it as other, just for the context of having that in the view for comparison. So if we move the standout quarter calculation to the view, we can adjust the colors, of course. I have come up with a neat TC color palette, and the others will be gray. And here we go. Looks like the current quarter is quite well positioned against the same quarter last year for Superstore. Q4 is like the strongest quarter leading up to Christmas. So yeah, I can visually see that we're quite on track. But still, I would want that the lines are a little bit thicker. What I can do here is then to create a set actually from this calc that I made for the standout quarters, and basically just tick other or the other three to distinguish what I want to have in and out of my set. And move this onto size, and ta-da, the lines will be a little bit thicker and might stand out just a little bit clearer against the rest of the set. So if you deal with this kind of calculations for duration, this is the easy calc, date diff, order date, ship date, or whatever you have, time to process, time to ship, many, many applications of that. And it can also be done relatively with the today or now function, and also be nested, like in the example I just showed with the week of quarter. Again, be cautious with just like calculating ship date minus order date. This will not work in most of the cases. Last but not least, a KPI for customer acquisition. So here we see sales by year of order date, or excuse me, it is the count distinct of customers for the year of order date. And from the sheer numbers that I see, I would say this is quite on track. But how can I identify that these customer numbers that I see are actually new or existing? Did they make their first purchase in that particular year or not? If we wanted to compute it with a row-level calculation, I would need to bring out all my customers' names in order to do that. But we can write a level of detail calculation called cohort and use date functions or dates within that to find out what is the first purchase date for each customer. So fixed on customer ID, I want to get the minimum order date. And this would be just like a new column in my data set that will give me that particular information. So it will be available to each and every transaction this customer made in their entire life as a customer with Superstore. So if you use this cohort date instead of the year of order date, I can shockingly see that Superstore has not done much for acquiring new customers, and that this year it's even worse than in other years. And again, I could use the last equals 0 calculation to get the latest value for my KPI here. So not only can you use dates like with minimum and maximum in the aggregate expression of a level of detail calculation, but you could also use it in the dimension declarations, and even with date trunc or any other date function that is available in Tableau. So this particular example I created actually for a customer who runs an amusement park and wanted to know from their Wi-Fi data how many distinct customers would visit a particular area of the park at a given day of the year. So basically we wrote this date trunc calculation for showing this on the part map, and yeah, to get the data right and not to bring all the distinct customer emails. So if we bring all of this together, we will end up with the great Superstore Metrics scorecard. I hope you like it. Do you? I just noticed, like during the presentation, I was a little bit nervous and skipped one of the things I promised in the agenda, which is how to deal with that year-to-date versus previous year-to-date function when it's about a custom fiscal date. Sorry, I was a bit fast. So basically, after I delivered this session at TC Europe, one of the customers I actually know who came to the session wrote me an email saying that he was struggling to do this based on his fiscal year that would start in October and is not conform with the actual calendar year. I mean, we're using today and really doing this on the calendar level, calendar year level. I basically sat down and was also a bit confused about this logic of it. It seemed hard to me. But I ultimately came up with that idea to just project all of my transactions and also myself 3 months into the future. So if we just basically add 3 months to each transaction that we have, so if we create that fiscal date here, October till January, that's 3 months, right? So we add 3 months to our order date and shift everything into the future. We do the same with today. So that's easy. It works because the number of days, if you think back to the year of date, it's always like the same amount. It's always 365 days. So we can simply, really simply, replace our fields from the calculation we just wrote. So if we just replace order date with fiscal date, and if we replace today with 3 months from today, we can just use it. So this is our fiscal year-to-date sales. Of course, it's way lower because it just started in October. And the fiscal year-to-date sales previous to basically get that and see that for Superstore, something must have been different last year based on if we would have the start in October. Maybe there was just not enough marketing. So with that, I hope that the presentation has been helpful for you. So this is titled Learnings and Homework. The ultimate takeaway from this session should be that the layout of your viz determines the type of calculation that you need to write in order to get the right numbers to display. Anything should be visual and also big numbers. They should provide the context that you need your audience to have for interpreting those numbers. I hope you have found at least one example that would be valuable to your business. Take a moment to reflect which one that could be. And anyway, just like in school, homework is the best way to learn by recreating at least 1 or 2 of these examples at home with your own data and see what it looks like. I have plenty of time to hang out in the room to answer your questions, 45 minutes to be precise. Please use the opportunity to find me here in the front. Alternatively, you can reach out in the community forum. Also, the workbook will be on Tableau Public. Thank you.